Okay, so monosaccharide structure could be written through Fissure projection formulas. Okay, this is actually a two-dimensional structure notation for showing the spatial arrangement of groups about chiral centers in a molecule. So, paano tong Fissure projection formula? The carbon atom or the carbon chain is positioned in a vertical arrangement with the carbonyl group, the C double bond O, ito yung functional group nila. Kung maalala natin, ang monosaccharides ay polyhydroxyaldehyde or polyhydroxyketone. That functional group is positioned at the top or near the top. Okay? And for monosaccharides, through Fissure projection formula, we could easily detect if it is a left-handed or right-handed molecule by having the highest numbered chiral center or the arrangement of the hydroxyl ion in the highest chiral center. So if the hydroxyl ion on that highest numbered chiral center is on the right, then therefore it is a D molecule. May mga nasa unahan siya D and then the name of the monosaccharide. Okay? Or if the orientation in space of the hydroxyl ion on that highest chiral number or highest numbered chiral center is oriented on the left, it would be a left-handed molecule or it will have an L on its nomenclature. So paano ba ito? Okay. So this is an example of a Fissure projection formula of two monosaccharides. Paano natin malalaman kung ito ay left-handed or right-handed molecule? So sabi ng Fissure projection, naka-arrange daw ang carbon atoms in a vertical manner. So this is carbon number 1, this is carbon 2, 3, 4, 5, 6. So this is a hexose with the CHO on top. So that would be C double bond O, H. Okay? Pag in-expand natin yung CHO na yan, it is C double bond O, H. Okay? So, looking at this, asan ba ang chiral center? Asaan yung mga chiral center? Carbon number 1, this is carbon number 1, and this is carbon number 6. So, this monosaccharide is actually an aldohexose because of the aldehyde group and a 6 carbon atom. Carbon number 1 is not a chiral center. Bakit? Kasi nga, meron siyang double bond O. Remember, for it to be considered a chiral center, dapat 4 single bond. So with the existence of double bond, automatic hindi na pwedeng maging chiral center ang carbon number 1. Okay? So carbon number 2. Looking at carbon number 2, so it is carbon number 2 dyan. It has 4 different groups. So this is hydroxyl is group 1. The carbonyl group, functional group is group number 2. Hydrogen is group number 3. And the remaining of this would be the 4th group. So with that 4 different groups attached in that carbon number 2 through single bond, so therefore carbon number 2 is chiral center. Carbon number 3. Carbon number 3 is also chiral center kasi nga ito ay merong 4 na grupo na naka-attach sa kanya through single bond. Carbon number 4, on the other hand, is also chiral center kasi ito yung group 1 niya. Ito yung group 2, 3, and 4. Okay, so carbon number 5 could also be considered as chiral center. However, for group number 6, hindi na siya pwedeng for carbon number 6 rather, it could not be anymore considered as chiral center because of the existence of H2. Kasi sabi natin, para maging chiral center, kailangan niyang magkaroon ng apat na magkakaibang grupo na naka-attach sa kanya or sa carbon atom through single bond. Okay? So, paano natin malalaman if this is a right-handed or left-handed molecule or right-handed or left-handed monosaccharide? Sabi kanina, okay, the hydroxyl group on that highest numbered chiral center should be oriented on the right for it to be classified as a D molecule, or pag sinabi nating D, it is a right-handed molecule. For the for it to be considered as a left-handed or L molecule, the hydroxyl should be on the left. So balikan natin. Sabi dito, ito daw ay D monosaccharide, or this is right-handed monosaccharide or right-handed form. Paano siya? Remember, we have 4 chiral center for this monosaccharide. And the highest numbered chiral center is carbon number 5. So, ang basis natin, si carbon number 5. Nasaan ba ang orientation ng hydroxyl niya? Ito ang left at ito ang right. Since ang hydroxyl ion na naka-attach sa highest carbon atom or highest chiral center for this example is oriented on the right, then therefore it is a right-handed molecule or D molecule or D monosaccharide. Dito naman sa second example, ito daw ay left-handed form of a monosaccharide kasi nga ang chiral center or highest number chiral center is at carbon number 5. The hydroxyl on that carbon number 5 is oriented on the left. Okay, so therefore that is a left-handed monosaccharide. Okay, so that's how you're going to distinguish or to predict if how a molecule is a left-handed or how is it, paano siya naging left-handed or right-handed molecule. Okay. Another property of a monosaccharide is that they are rather stereoisomers. Okay, so isomerism is possible, stereoisomerism is possible. Ulitin natin, isomers have the same molecular formula. Okay, but for stereoisomers, still they have same molecular formula. They have the same structural formula, but the atoms in that molecule is oriented in different orientation. Okay, so they are oriented in different orientation in space. Okay, so merong dalawang klase ng stereoisomers. We have enantiomer, and the second one is, so this one should be second, diastereomers. So dalawang klase, enantiomer and diastereomer. Paano mo makaklasify ang na enantiomer ang dalawang molecule? If they possess a non-superimposable images. Paano natin masasabi na non-superimposable image ang isang molecule? We have to consider the chiral center of that molecule, and all the hydroxyl group should be oriented in opposite direction. So they should have opposite orientation in space. Paano opposite? Okay? So tignan natin. We have 4 chiral centers here on molecule A, and molecule B is actually similar to molecule A. If you're going to count, molecule A will have 6 carbon atoms. Ilan ang kanyang hydrogen? 1. Okay, so you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that is C6H12. And oxygen is 6. Okay. Looking at molecule B, so we have 6 carbon atoms as well. Hydrogen is also 12. And oxygen is also 6. So they share the same molecular formula. Okay. So they are isomers. They also exhibit the same structural form kasi parang parehas naman si carbon number 1 ay CHO, carbon atom number 2 ay identical din naman siya, magkaka-identical lahat sila. Kanya lang, ay sinasabing different orientation in space, ay ito, yung mga hydroxyl ions ay different ang orientation nila. So, kung si carbon number 1, yung hydroxyl niya ay oriented on the left, si carbon atom number 2 naman kay molecule B ay oriented on the right. Okay? With that, stereoisomerism is possible. But what type of stereoisomers? Sabi dito ay enantiomers because all the hydroxyl groups attached on those chiral centers should be on opposite orientation. Tignan natin. Okay. So, the hydroxyl group on this first chiral center, kasi ito yung unang chiral center, is oriented on the left, while as on the other molecule, it is oriented on the right. Okay, so opposite siya. This hydroxyl is oriented on the right, and dun naman sa kabila ay nasa left. So, baliktad. This one is left, and that is on right. And the last chiral center, the hydroxyl is oriented on the right, and the one is on the left. Since everything is in all hydroxyl is oriented in opposite direction or orientation, then therefore this is an enantiomer. This is actually these molecules are the left and right-handed form of a monosaccharide. This is, since molecule A is a D molecule and molecule B is a left or L molecule. Okay? Left-handed. So, tatandaan lang, para maging enantiomer, lahat ng hydroxyl sa chiral center ay in opposite orientation. Now, for it to be a diastereomer, so that's the second, for it to be a diastereomer, hindi lahat daw ay not oriented on opposite orientation. So therefore, kung hindi siya na-orient on different manner, then therefore it is not a mirror image. Okay? And a special type of diastereomer is an epimer. Pag sinabing epimer, sa isang chiral center lang daw sila nagkaiba. Okay? So, let's have this example. Okay. We have molecule A and molecule B. Still, it is an isomer because they share same molecular formula, C6H12O6. They have similar structure. However, the orientation of the hydroxyl are just different, making it a stereoisomer. Okay. On the first chiral center, at carbon number 2, the hydroxyl is oriented on the right. And for this chiral center on molecule B, nasa right din. Okay, so hindi sila opposite. For stereoisomers, meron ng the same orientation. So this is a mixture of same and opposite orientation. Kung kanina sa enantiomer, all are in opposite orientation, for diastereomer will have same and opposite. Okay? And for particular pag sinabi namang epimer, meron siyang same at isa lang yung opposite niya. Okay, so going back, so this chiral center's hydroxyl ion is on the right while this is on the left. So kung kanina this is same, oriented on the same manner, the second chiral center's hydroxyl ion is oriented in different or opposite. Okay, gamitin na lang natin yung opposite. Okay, so nandun siya sa opposite. Okay? The third chiral center's hydroxyl ion is oriented on the left for molecule A, while as for molecule B, it is on the right. So this is opposite. Okay? And the last chiral center, the hydroxyl is on the right, and same is true for the molecule, for the hydroxyl in molecule B. So this is same. Okay. So dahil may same at may dalawang opposite, okay, it is a diastereomer but not an epimer. Hindi siya pwedeng maging epimer kasi sabi natin kanina, for it to be an epimer, there should only be one different orientation. Dahil sa dalawa, ang different orientation natin, hindi siya pwedeng mag-fall as epimer. Diastereomers lang siya. Okay? So, ayan. Sabi niya, merong same and may more than one. Kasi ang requirement kasi for it to be an epimer, dapat isa lang. Since dito, more than one yung opposite. Okay. Next example is a diastereomer and at the same time, it's an epimer. Paano siya naging diastereomer? So, meron tayong same. So, yan ay same. Ito ulit ay same. Okay, so basta pag may same, diastereomer na siya automatic. Okay, ito naman ay opposite. Okay, and this one is same. Same orientation. Okay, with the presence of same orientation and an opposite, it is a diastereomer. But because there's only one opposite orientation, then that makes it an epimer. And we call that yung dun sa kung saan nag-opposite na yan, this carbon atom, aside from being a chiral center, it could also be known as the epimeric carbon atom. Epimeric carbon. Okay? So, epimeric carbon atom siya kasi dyan sa carbon atom na yan, dyan lang nagkaiba yung orientation ng hydroxyl. So, ulitin natin. For it to be an enantiomer, kailangan lahat ng hydroxyl ay oriented on different sides. Kung yung isa nasa left, dapat nandun sa right para maging non-superimposable mirror image. So, all hydroxyl should be in opposite or different orientation. For it to be a diastereomer, okay, so meron ng same. Meron ng same orientation, so this is a mixture of same and opposite orientation. Diastereomers will have same and opposite orientation. For it to be specifically known as epimer, meron din siyang same, pero one opposite lang siya. One opposite orientation of the hydroxyl ion.